Okay, let's go over 11.1, which is a review of solving quadratic equations. Chapter 11 in general is going to cover a lot of quadratics and all the different ways that we can solve quadratics, some of which we already know. This is going to be one of our review lessons here for 11.1, which is going to kind of focus on factoring. We're going to go over the steps here for solving a quadratic by factoring. If we look at this first example down here, you'll notice that the leading coefficient is positive. Okay, so that's a good thing. You want that leading coefficient to be positive. Notice how we have it in that standard polynomial form where we have the x term, the squared. So that's our x squared term. We have our x, and it doesn't matter if that's positive or negative. And then we have our constant. We usually refer to those as a, b, and c, which I already put down for the constant. Another thing you might want to just kind of make a note of here is that it's equal to 0, and that's a good thing. You don't want anything else over there besides 0 because we're going to use the 0 product rule. Okay, so let's dive right into that first example there, and we're going to use the standard product sum rule. All right, remember that number represents, or that value, that term represents our sum, and that term represents our product. And one of the things that is usually the most helpful when you do these kind of problems is to kind of start with a product. And this one's not very complicated, but you start with the product and you just kind of factor it out. And obviously 2 doesn't have a ton of factors. So you have 1 and 2. And then you look and think, okay, do any of those factor pairs make a sum of the x term, the 3x? And they indeed do work. 1 and 2, if you add them, will make 3. And usually I tell my students to kind of avoid putting signs in yet, just kind of leave these open-ended, 1 and 2, because then you can mess around with the signs, make them negative, make them, make one positive, make one negative, etc. But we don't have to do that for this one. They're both positive. And so we're going to solve it like that, and we're going to set it up in kind of this binomial format. And since 2 and 1 were our factor pairs, you just put plus 1 plus 2 and plus 1, and then what you do is you kind of divide that up into your separate equation. So we've got x plus 2 equals 0, and then you also have the equation of x plus 1 equals 0. And then you go ahead and solve those equations, which is, I know, really tough for some of you, but we'll try to make it through this. And then this one's going to be x equals -1. And there you go. Those are your solutions to your quadratic. Now, if I put this in solution set format, I can write this as just a set of -2 and -1, not to be confused with an ordered pair. So there's your solution right there. That's what x is equal to. All right, now down here, you'll see for number 2, it is not in that standard format. And so what we want to do is we want to get everything over to one side. We want that leading x squared term, and I know that's t squared, but we want that squared term to be positive, which it already is. And then let's move this 9 term over. And so when we move that 9 term over, we're going to get t squared minus 9 equals 0. And if you've been in class or if you've been kind of awake lately, you might notice that that's a difference of 2 squares. I usually just refer to that as DOTS. Difference of 2 squares, and if it's a difference of 2 squares, you know that it's going to turn out to be a plus-minus situation, where you take the square root of the first term, put that there, so the square root, I don't need to probably write this out, but I'm going to, the square root of t squared is t, it's really plus or minus t, but I'm just going to write t, and the square root of 9 is 3, so that's your other term, so plus 3 minus 3. So now when it comes down to solving it, you're going to have t plus 3 equals 0. That's one of your equations. And the other equation is going to be t minus 3 equals 0. And again, those aren't very tough. This t equals -3. And this t right here equals +3. Now don't assume they're always going to be like that. I know sometimes people see that. They're like, oh, I know one answer is going to be positive, one answer is going to be negative, and that's always how it's going to be. Well, I mean, the first example kind of showed us that didn't happen. This one came out to be just -3 and 3. I should also point out that when we're solving a quadratic, we're finding these are the x values. We're figuring out what x is. Well, in this case, actually, we were looking for the t values. But we're essentially looking for that value that's the leading coefficient that's in front of that leading coefficient. All right, now this one right here, just a little bit different, but not that much different. What you might notice here is you've got a leading coefficient that is not 1. Now let's kind of go over what you want to do. When the leading coefficient is not equal to 1, what you want to do is you want to take the A term, and usually I just tell people to stick with the coefficients, and take the C term, 2 and 49, and you want to multiply them. So 2 times 49 is 98. Okay, so then you got that. And then what you want to do is you want to kind of factor out 98. So I'm going to do that over here. So 98, I'm going to look for as many factors of 98 that I can. So I've got 1 in 98. We've got obviously a 2 and 49. 3 does not go into it. 4 does not. 5 does not. 6 does not. 7 and 14. And you just kind of maybe have to kind of use your calculator for that one. But yes, that's not a very common pair of numbers there that you kind of just know off the top of your head that 7 times 14 makes 98. But right there is your pair, your factor pair. Now remember, when you do this alternate product sum method, you have to do a little bit more. So you have to take the A term and just write out 2x, like that. And then what you do is we're going to put the 7 and we're going to put the 49, or not the 49, but the 14 there. And we want those to both be positive because we want to make positive 21. And then what you do is you look at them like ratios. You look at them like fractions and see if they reduce. Now the first one does not reduce. This one right here will reduce to 1 over 7. Break that down, we get 2x plus 7. And then the other binomial is going to be x plus 7. Because that's what we had. We have an x here and we had a 7 there. And then that all equals 0. And then what you do is just kind of go through what we've been doing, which is just make your equations. So you got 2x plus 7 equals 0, and then you have x plus 7 equals 0. And this first equation, there's a little bit more to that. So I'm going to take away 7 from both sides. I'm going to solve it like a two-step equation. And if that's difficult for you, make sure you go back and review how to solve two-step equations. Hopefully that at this point in the class, it's not terribly difficult for you. But there's your answer. You got negative 7 halves. Or if you want to put negative 3 and 1/2, that's fine. But as you know in algebra, it's okay to leave things improper as long as they're simplified, which it is. And then for this one, we're going to take 7 away from both sides, and then you get x equals negative 7. Okay, so sorry, these got messy. But there's your solution set. So we've got negative 7, and the other solution is negative 7 halves. Now the next one, you're going to notice that there's no 0 there. So if there's no 0 there, we want to make it so that it is. So that means we have to take this term and move it over to the left side. So we're going to move it to the left-hand side of that equation, or the polynomial, I should say. And so you're going to get 8v squared. Now that was a positive 2v, so it's going to become minus 2v on the other side. I'm going to keep 15 the way it is, minus 15 equals 0. Our leading coefficient is not 1, so we want to use that alternative modified product sum method, which means we're going to take the A term and we're going to multiply by the C term. So 8 times 15 is 120. All right, so now what I'm going to do is I'm going to factor out 120. It's always good to start with the lowest number and the other, the highest extreme, 1 and 120, and then you get kind of just keep going. So 2 and 60 makes 120 when you multiply them. 3 and 40 makes 120, and we're looking for a sum of 2. So I haven't seen any numbers that are going to give us a difference of 2. So 3 and 40, that can give us a difference of, at the most, 37. And so then we've got 4 and 30. We've got 5 and 24. All right. We've got 6 and 20. 7 does not work. 8 will work because we just used that. We are going to do 8 and what else was it? 15. 8 times 15 is 20. Now 15 minus 8 makes 7. So again, we're not quite there yet. So then we've got 10 and 12. And there it is. I think that's the last possible pair anyway. But if you got there earlier, I think I said this in class, but if you got there earlier and you're like, I knew it was 10 and 12, you don't have to go through all this whole process of factoring everything out, but it doesn't hurt to do that if this is something that is difficult for you to do. Okay, so there's our factor pair, 10 and 12. That will definitely make 2 as long as you do 12 minus 10. Get 8v. I'm going to write that twice. And then we want to use 10 and 12. And we want to make negative 2 out of those numbers. So I want the negative to be attached to the 12, positive attached to the 10. And then both of those can reduce. So 8 over 10 reduces to 4 over 5. And 8 over 12 reduces to 2 over 3, because I can divide those by 4. And now I'm going to break those down into binomials. So you got 4v plus 5. See that? 4 and then plus 5. And then right here we've got 2v minus 3. And then I'm going to set that equal to 0. And then I'm just going to go ahead and solve it, or solve each equation. So there's one solution. Sorry if I'm not showing all my inverse operations, but at this point in the game, I hope this is becoming second nature to you. So there are your two solutions. So you got negative 5 quarters, 5 fourths, negative 5 fourths, and you got 3 halves. Those are our x's. Well, in this case, it's v's. All right, number 5 is a little bit ridiculous because it looks like you almost have everything that you need to solve it, but you don't. So what you're going to need to do is you need to get everything over, because we want that term to be over there, but we can't set up equations where we have a plus 9 equals 3 and then we have a plus 7 equals 3, because it's just not going to work. We can't say, well, a is equal to negative 6 and a is equal to negative 4, because it's not going to work out that way. So that's not going to work. Erase all that. I want to kind of forget about that. So what I want to do here first is in this case, let's work out that binomial right there. So we've got a squared plus, now I'm just going to kind of do product sum in my head. 9 and 7 make 16, so I'm going to put 16a. And 9 times 7 makes 63. And then I'm going to make that equal to 3. And then again, I want that side to equal 0, which it's not 0 yet. So I want to do a squared plus 16a plus 60 minus 3. Clean that up a little bit. You get 16a plus, I should have put 63 there, sorry. 60 equals 0. Then I'm going to factor, just using the product sum method. And this is one of those problems where I can kind of see what 60 is, but I'm just going to write it out anyway. 60 is our product number, so we're going to do 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. And bingo, there it is, 6 and 10. Like I said, if you see that right away, you don't have to go through this whole process of listing it all out. That's great if you can see it right away. Saves time. Okay, once you get good at this, most people kind of skip that step. But I'm going to put plus plus because that is what we have. And then I'm going to solve those equations separately. So I've got a plus 6 equals 0. So there's one of your solutions, a equals negative 6. And the other equation is going to be a plus 10 equals 0. So a equals negative 10. And there it is. So our solution set in this case is negative 10 and negative 6. Those are our a values. All right, number 6 has a lot going on. You might notice that we have a degree of 3 here. Everything's got an m, so there's probably going to be a GCF that's going to factor out. And also, this side does not equal 0. So let's first move that over to the left-hand side of that polynomial. So we get 4m cubed minus 23m squared minus 6m equals 0. I'm going to look for a GCF. There is a GCF. Now, number-wise, we almost could take out a 2, but 2 does not divide into 23. It does divide into 6. But we can take out a letter. So they all have an m. That has 1m at least. I mean, there's 3 of them. This has at least 1m, and this one has exactly 1m. So our GCF is going to be m. And then you pull that out, and then you get 4m squared minus 23m minus 6 equals 0. use that modified product sum method. I'm going to take the a term and multiply by the c term. 4 times 6. I know it's 4 times negative 6, but I'm kind of ignoring that right now. You just get 24. And then if you factor out 24, you got 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I'm looking for factor pairs that are going to make the sum value of 23. Obviously, it was 1 and 24. Like I said, if you see that right away, just go ahead and throw that down on the paper and just go with it. So now what I'm going to do is I'm going to take the a term and write that out twice, 4m and 4m. And then I need to make negative 23. So I'm going to put negative 24, and I'm going to put positive 1 there. That negative 24 plus 1 does make negative 23. Next thing you want to do is reduce those. You can reduce these by 4, so you get 1 over 6, and this one does not reduce. So now what you're going to do is you're going to take your solution. So we've got m right here. We've got m minus 6. That's your first binomial. And then the 4m plus 1. That will equal 0. And then I'm going to set up my equations. One of the equations is super simple to solve. There it is. M equals 6. The other equation, not that hard either. It's just 2 steps though. Sorry if I'm not going to show all my work, but I got 4m equals negative 1 when I move that over. And then I divide by 4, and I get m equals negative 1/4. So there you have it. So your solutions, your m's, are negative 1/4 and 6. And that does it for section 11.1.